All right, we're good.
All right, I cannot see the folks joining in. Good afternoon, everyone. All right. Good afternoon and happy Earth Day. Thank you so much for joining us. It's such a special day. Today is our 5th Earth Day. We are very excited today, not only because it's Earth Day, but I'm truly excited because we are going to be talking about one of my favorite animals, sharks. So super exciting Sustainachella. So while we wait a couple of minutes for folks to join in, I would like to start warming up the chat. If you're new to Zoom, the chat is in the middle on the bottom of your screen, and you can make comments to everyone. Just make sure you add panelists and attendees so you're sharing your comments with everyone. And for the folks that are new to virtual Sustainachella, just wanted to share with you that, one of the goals that we have is to try to take you away from the COVID world for a moment and come to a happy place. And I know that we are definitely here to support you. And if there is anything we can do to support your mental health, please let us know. After Sustainachella, we'll be sending you out a survey. So just share your thoughts with us, anything you would like for us to be doing. And well, enough of talking. Right now we have Elizabeth Wheaton, our Environment and Sustainability Director, here with us today. So I want to pass the mic to Betsy. And so we can start warming up the chat. All yours, Betsy.
Awesome, Flavia. Thank you so much. And I want to give a special thanks to the whole environment and sustainability team that is making these virtual Sustainachellas possible. So thank you, Flavia, Yanni, and Alicia for all your hard work. And, we're excited. Today is Earth Day. And today is a special Earth Day because not only is it the 50th anniversary of Earth Day, it's also an Earth Day for us to think and reflect. And I think, COVID has given us that opportunity to see the world begin to heal itself. But also it's giving us a chance as individuals to turn inward and reflect. So, in the chat, if everyone wants to just kind of give some examples of things that they're doing in their life that are more sustainable, how they've made changes in the last month to think differently about, their own mental health, how they're thinking about reusing and reducing waste, anything that relates to the environment. I think there's so much that we can do. So I see meditating, riding bike, and driving less. I think that's a one that a lot of us are taking advantage of. I know for myself, it's cooking more. I didn't realize how much I love to cook, and I've been experimenting with a lot more vegetarian and vegan recipes, which has been really fun, and finding a lot of options that I didn't know were out there. All right, let's see what else people are saying in the chat. Healthy foods, walking, planting veggies. I think we're going to have a great webinar on Friday all about plants, so please tune in. Riding bike, using more natural light. Oh, I love that one, Mitch. I think that's a really good one. We don't really need to have lights on if we have natural light. Going to the farmer's market, cool. All right, it looks like we're at about 12:06, so we can get this started. I encourage everyone to use the Q&A box at the bottom if you have questions, and we can ask Catherine and our sustainability team at the end. And also throughout the duration of this workshop, please use the chat, interact with the fellow participants, and we are here for you. So any questions that come up or any dialogue you want to have, run with it. All right.
All right, thank you. Thank you, Betsy. All right, so just some housekeeping here before we start, guys. Some of you already might know, yeah, here we go. Super excited again, Fin-tastic Sharks coming soon. So just some housekeeping here. All the participants are muted and videos are disabled. This is in order to avoid some Zoom bombing while we are doing the workshop. If you'd like to ask a question, there is a Q&A box that you can send your questions there. And also in the chat, please, again, share your comments with the whole group. select everyone or all panelists and attendees and make sure that, you know, you're active, sharing your thoughts during the workshop. Betsy mentioned about Earth Day. Another reminder that it's not only Earth Day, but also Earth Month, and we have several events coming up. So stay tuned, check it in our MB Rising Above /Sustainachella. And we not only have events in April, but we are also coming up with workshops in May. So check it out, a lot of good stuff coming in. And again, in the survey we are going to send out, let us know about topics you would like us to bring it for you. And finally, super excited, starting the day with sharks. Welcoming today, Dr. Catherine MacDonald. Thank you so much for joining us here, Catherine. And I'm going to do a quick brief intro here for Catherine. Catherine is really an amazing woman and outstanding professional, so I'm very excited to have her here. She teaches at Erasmus at the University of Miami, and she's also the co-founder and director of the Field School, which is an awesome marine science and outreach organization where she trains future scientists to conduct research. So Catherine, I'm going to pass it to the presentation to you for you to take over. But before you start sharing your presentation, we would love to learn a little bit about you. So I wanted to ask you a few questions. And the first one, before we dive into the shark world, how did you end up in that shark world?
I'm one of those people who gets to do for my job what I wanted to do when I was 5 years old. It's something I have in common mostly from what I can tell with other marine biologists, policemen, and firefighters, and we're about it. But when I was little, I saw a shark get caught by a shore-based fisherman in South Carolina where my great-grandparents lived, and all of my sympathy was for the shark, right? People on the beach were like, oh my God, that was in there with our children. And, you know, I was like, and I was definitely team shark from then on. So yeah, I love working with them, and I love working with students.
That's awesome. And Catherine, I think, you know, I was going to ask you that before I go into the question. I think that there is a lot of fear, like that sentiment of fear going on right now with everything that is happening. And I think one of the questions that you probably get always, right? Because a lot of folks do have that sentiment of fear for sharks. So just wondering if you, one, ever had that sentiment, and whenever you're taking folks out in the field with you, like how can we transfer that sentiment of fear into a different sentiment like love, like gratitude?
So for me, part of it is separating, and I'm a scientist, right? So I think about these things maybe a little differently than most people, but it's separating like the physiological reaction that your body has to the potential threat of a predator from like your feelings of lack of safety, right? So you get flooded by adrenaline. I still do sometimes when I'm handling an animal, when I'm in the water with an animal. That's normal. There's nothing wrong with it. But working to separate that response from the actual sense of risk that you have, because the reality is that most of us have hardly ever gotten in the ocean without a shark or a ray being aware of it, right? They have incredibly good senses. They're everywhere. If they were out to bite us, almost no one would go swimming without getting bitten. They're very actively not out to bite us. For the most part, they're really out to avoid us, which is why you don't know that they know that you're there. And so refocusing on sort of that recognition of the fact that even as you might feel anxious, you're actually safe, is an important tool, I think, for managing both my work, but also our lives right now, right? Because we feel this constant existential worry, but most of us, if we're making really good choices at this point, are pretty safe, and we're helping to keep others safe by making those choices. So it's just separating feelings of risk from actual risk. And when it comes to sharks, your actual risk is almost nothing. Coconuts falling from palm trees kill more people every year than sharks do. Vending machines kill more people every year than sharks do. People don't get their soda. They try to shake it, it falls on them. Staircases, toasters.
But yeah, Yeah, that's about
Lots
right.
of things that we don't think of as risky are much more dangerous to us than sharks.
Totally. All right. Well, Catherine, thank you so much again. I'm stopping sharing my screen right now. So the screen is all yours for you to start with sharks, the shark conservation presentation. And yeah, guys, I'm super excited because we're going to be learning a lot of cool things about sharks. And make sure you pay attention because you know what happens afterwards. We have our Kahoot, and the folks that can answer the greatest amount of questions correct, they get some prizes. Okay, here we go.
Okay, hi everybody. So before we totally dive in here, my email is right there at the bottom of this slide. So please, if you have more questions about sharks, especially if you have kids at home who have more questions about sharks, don't be shy. I'm more than happy to try to answer them. We may or may not get to do a bit of a Q&A at the end of this, depending on how excited I get about the slides that I have and how fast I talk. So we'll see how we do. So let's start by answering the question, what even is a shark? And the answer is, it's a fish. And for some of you, that's really obvious and you're rolling your eyes at me right now and you're like, this girl has a PhD. And for some of you, you're like, oh, really, huh? Because people ask me if it's a mammal pretty often. When I say it's a cartilaginous fish, what that means is that its skeleton is made up of cartilage rather than bone. So we have these big, dense, thick mammalian bones, right? They give our bodies structure, they protect us from injury. Sharks instead have skeletons that are mostly made up of cartilage, which is the stuff that makes up the flexible parts of your ear and your nose. And the advantages of that are that they are much lighter and much more flexible than bone, right? And protects you from particular kinds of injury. You're not going to break him, but provides less physical protection from other types of injury. So sharks are vulnerable, for instance, to being rammed and being injured that way because they don't have that nice bony rib cage like we do to keep their internal organs safe. Sharks are extremely ancient as a group of animals, right? Sharks date back further than trees. The oldest tree we have in our fossil record is about 385 million years old. They date back further than Pangea, which is about 335 million years ago. And that's, of course, when all of the continents formed a supercontinent. They date back further than dinosaurs, which are about 240 million years ago. So the earliest sharks in the fossil record are between 400 and 450 million years ago, depending on how you count. So people will sometimes talk about sharks as primitive, right? As though that means that they're stupid or unevolved. But the reality is that what that means is that sharks got the design really right the first time, right? They came up with an evolutionary strategy that worked great, and they've been making it work ever since. So anybody who says that their ancientness means that they're less cool is totally wrong. Their ancientness means that they're way more cool, and they've been able to survive many mass extinctions, huge changes to our planet, and to still remain a really critical part of our ocean ecosystems. Sharks are actually really, really diverse. If I ask people to name sharks, and if we were all in person, I would definitely do that. So hey, let's try it in the chat. Name the first 3 sharks you think of. Tiger sharks? Yep. Hammerhead? Nurse shark, I like that, Paisley. Paisley's in my class at Rasmus. Thresher, goblin shark. You guys are too smart. I always get great white, bull shark, tiger shark, hammerhead. And that's pretty much it. You guys have come up with like much better lists than I normally get. But within some limits, most of those are still pretty like sharky looking sharks, right? You know, semi-pointy face except for the hammerhead. You've got the big dorsal fins. You guys have such good answers here. Now I just want to talk about Greenland sharks. But the reality is that there are more than 500 species of shark out there, right? If you include the rays as well, it's over 1,000 species. And the vast majority of them are about this big, right? So people name those sharks, and so they think of sharks as big and predatory and potentially dangerous, but the vast majority of sharks couldn't really hurt a person if they wanted to. They are a terrifying murder machine if you're a crab. But if you're a human being, they don't pose a meaningful risk to you. So our public vision of what a shark is and the reality of what a shark is are actually quite different. And the kinds of animals that you see covered on Shark Week are typically a very small predatory fraction of the total variety of shark species that exist. We have among sharks species as different as the whale shark, which is the largest fish in the ocean, and the teeny tiny like pocket dwarf lantern shark, which as an adult would fit in the palm of your hand. And the thresher, which are super cool. I put him on there just because I think he's really cool. Sharks occur from the equator to the poles, right? The greatest number of species are found around the equator in tropical and subtropical waters. The reason for that is most, but not all, sharks are what are called ectotherms, which means they're cold-blooded. And those cold-blooded animals, their body temperature is determined by the temperature of the water around them. So if you're an ectotherm, it's a lot easier to live in a place where the water is already at a temperature that like bodies are pretty good at. If you live in really cold water as a shark, you need some very cool specialized adaptations that I don't have time to talk about right now. But they're found in every ocean of the world and in freshwater too. Most people know about the bull shark, that they're able to move between fresh and salt water. Super cool ability. There's also a group of 5 species of sharks in the genus Glyphis in Southeast Asia that live exclusively in freshwater. And we know from the fossil record that there were other freshwater sharks in the past. And sharks occupy a range of ecological roles. That means that they can be both apex and mesopredators. And we're gonna talk a little bit more about what that means in a slide or so. But basically, apex predators are at the very top of that food chain, right? And mesopredators fall anywhere under that, where they eat other animals, but are also eaten by other animals. Sharks are also what's called K-selected, right? And this is an ecology term, because ecologists really like to make up fancy words that make us seem smart to explain basic concepts. But sometimes it also saves us time. So K-selected means that an animal has few offspring and devotes a lot of energy and resources to producing each of those offspring. Once they're born, they have a very high rate of survival, and they're likely to make it to adulthood. And our selected species, on the other hand, like our friend the fish here, have many, many offspring, often invest very little in each one. Some species of bony fish can release millions of eggs per year. So they're spawning, they're creating tons of offspring in the hopes that just a few of those will make it to maturity. They are both devoting similar amounts of energy to creating offspring, right? But with different investment strategies. Create a ton, hope if you make it. Create a few that you're giving everything to, invest a lot in them, and hope they make it. So those strategies mean that sharks are vulnerable to overfishing in ways that other fish aren't. So if you catch a juvenile shark, you're catching, it's the equivalent of catching a huge number of juvenile teleost fish, right? Because that one individual shark might be all of its mother's reproductive output for 2 or 3 years. And so sharks have a real difficulty coming back once they're overfished, because females can't ramp up production. In those other teleost fish that produce lots of offspring, they can ramp up production pretty easily, because usually if you reduce the population of adults, there's more resources available to juveniles. They survive at greater rates, and their population bounces back pretty rapidly, because juvenile sharks should already be surviving. They get into real trouble if they're being overfished. So here's that food pyramid we talked about. We've got At the bottom, we've got our photosynthesizing algae, right? Plants that are producing energy from the sun. Then we have the tiny microorganisms that make up zooplankton in our marine systems that eat the plankton and then are eaten in turn by mesopredatory fish. And you can have multiple levels of mesopredators, but a lot of sharks do occupy, because they're not that big, that mesopredatory niche where they eat smaller fish and are eaten by larger sharks. And then you have the large sharks that we sort of touched on that tend to be featured in Shark Week that occupy that important apex predatory role. So if you think about that stepped pyramid, at each step, you're losing 85 to 90% of the energy that's being produced. So of all of the energy that is produced through photosynthesis, only 10 to 15% of that is represented in the biomass of the zooplankton that feed on that plankton, right? Lots of energy is lost at each step. And that's the reason why you need a big field to feed one cat, right? Because it's not a one-to-one conversion of that energy. So as you move up trophic levels, it takes more and more energy below it to support that animal at the top. It's why the total biomass of predators shouldn't be that large, ideally, right, in a healthy system, and why overfishing animals that are below them in the food chain can really affect shark population health and survival. Ecologists like to talk about marine food webs as being controlled either from the top down or the bottom up. So if it's bottom up controlled, the thing that shapes the food web is the amount of primary production, the amount of plants photosynthesizing. And if it's controlled from the top down, it's shaped by the actions of predators, right? Which can help limit population sizes of species below them, can help prevent the spread of disease in species below them or undesirable traits, because sharks tend to target the weakest or sickest individuals as predators. That just makes their lives easier. And they also can change the behavior of fish, right? So a fish that feeds on seagrass, if there's no risk of being eaten by a shark, might spend its whole day out there, you know, just chomping down on seagrass. But knowing that there's a risk of being eaten by a shark, it stays near its hiding place. Maybe it feeds at specific times that it thinks its risk is lower. And so that top predator can really shape the structure of the ecosystem overall. So very briefly, we'll talk about sharks here in Miami, right? People tend to think that because we're a big city, we don't have wildlife, but in fact, we have the most incredible variety of sharks. Don't get worried, we'll talk more about it if you are. But offshore from Miami, I regularly catch sandbar sharks, which is that beautiful girl that you see there on top, and both large and small great hammerhead sharks, which is that beautiful lady that you see below. And we know that both of these species, great hammerheads, were downgraded to be listed as critically endangered by the IUCN in 2019. Sandbar sharks have been so overfished that the fishery is currently closed to everything but research, and they're not expected to rebuild for many decades because they have a very low reproductive rate. Both of these shark species are threatened, and we have evidence that they may come here to Miami to find mates, to give birth, that they may find food here, they may spend early parts of their lives here, especially in Biscayne Bay, which is a place that they can try to avoid predators and find food and grow up big and strong enough to kind of venture out into the wider ocean. And just north of us, we know that lemon sharks, for instance, like to aggregate in large social groupings as adults. So the choices that we make here in Miami actually really do matter to shark conservation. People tend to think that these are problems that are far away, that if the problem is finning, the problem is demand for shark fin soup, and that's not something we mostly eat here. Or tend to think that if the problem is, you know, pollution, well, Miami is a big city, so like we should be concerned about pollution in places that are pristine. But the reality is that the choices that we make on a daily basis in terms of fertilizing, in terms of dumping, in terms of making sure that we clean up our fishing gear, do make a difference to shark populations, and not just to nurse sharks, although I care about them too, but to species that really could use the conservation help. So I want to talk a little bit about shark behavior that might surprise you, because I think that these kinds of facts are one of the best way to overcome people's instinctive fear of sharks. And one of them is preferential relationships. So a study of juvenile lemon sharks in Bimini found that they have long-lasting friendships, right? I mean, they don't call it friendships because we're scientists. They call it stable associations. But some lemon sharks like hanging out with other individual lemon sharks. Some lemon sharks don't really like each other. And this initial finding that they found by observing them socially over time suggested that, their hypothesis was, well, they must be related, right? Because in the animal kingdom, we know that being genetically related often is a reason to form alliances. In this case, they ran the genetics to find out. And the answer is no. They're not more closely related. They're not strategically trying to advance their genes. They just have friends and frenemies and folks that they like and don't like. One of the things that's really incredible about that is it means that these juvenile lemon sharks can, A, distinguish each other, right, as individuals. In order to have a friend, you have to be able to recognize that friend. And B, they can remember their previous interactions over the relatively long term. In order to greet and hang out with your friend that day, you probably need to remember that you hung out with them yesterday and it was fun and you liked it. So this is just one way that we're starting to open the lid a little bit on shark cognition, which is very poorly studied, but I think a really exciting coming field for shark scientists. You also have, in some species of shark, especially the scalloped hammerhead, protective schooling, which is the process by which, when the school feels threatened, larger individuals move towards the exterior of the school, smaller individuals group in the center, so that whatever threat is encountering that school will meet the largest individuals who are best equipped to face it first. And that's another sort of strategic protection of the vulnerable action that people really didn't expect to see in sharks. Finally, one of my favorite studies of this looked at social learning in juvenile lemon sharks. Juvenile lemon sharks are one of the most well-studied species of shark, in part because they're sharky sharks, right? They're carcharinids, but they're also relatively easy to work with. They do well in captivity. And they're abundant in Bimini, which is one of the oldest shark research stations in the world. And so we know the most about them. This study trained juvenile lemon sharks to perform a task for a food reward, right? So the little guy was taught painstakingly over time using reward conditioning to touch that pole with his nose and then go touch the target with his nose. And if he did those two things in the correct order, he got a food reward. And they found that it took a pretty long time to train them to do this, but they could learn to do it. And that the more training you did, the more reliable their performance of it became. But then the thing they added to the study that made it really fascinating was they let another juvenile watch them perform this task after they'd been trained. Never seen it before. And they found that a juvenile who watched another trained juvenile do the task could learn the task significantly faster than a juvenile that was naive, that had not received any training or been able to observe another. So they're actually able to learn from each other, which is also cognitively really challenging and exciting. Finally, one cool afternote on that study is that after they released those juveniles, a year later, they recaptured a few of them, a small subset of the sharks that had participated and been trained, and they found that they remembered the task, right? They weren't able to perform it as well as they could when they started, when they were released, but they clearly remembered the task and knew they were supposed to do something and knew it involved touching those poles, and were able to pick it back up really quickly. So this is just some of what we're starting to learn about shark behavior and cognition. It's very difficult to study, especially because for a lot of large species, it's difficult to keep them in captivity. It's difficult to make them do anything they don't want to do. It's difficult to follow them over time. even, no matter what you want. Juvenile lemons are a bit easier because they're very strongly attached to particular mangrove habitat. So you can release them and then go get them later and they'll pretty much be there. But for large adult sharks, that's just not true. They're also very difficult to put in a CT scanner or, study in a lot of the other ways that we study cognition of terrestrial animals. So I think we're still developing some of the tools that are going to be used for this, but I also think that it's one of the most exciting areas of research that shark scientists are currently working on. So currently, about 15% of all shark species are evaluated by the IUCN, which is the UN, an impartial body that uses science to evaluate the conservation status of every species on Earth. That's their goal. There's a lot of species. It's going to take them a while. Has found that 15% of shark species are critically endangered, or threatened with extinction. That sounds not great, but like not that bad, right? 15%. On the other hand, 47% of shark species are data deficient. That just means there isn't enough science on that species to know what their conservation status is. People tend to think when I say this that I'm talking about deep sea sharks. But actually, many sharks that we think of as important and that we see all the time qualify as data deficient. The Western Atlantic population of the nurse shark is data deficient. The Western population of the Atlantic population of the southern stingray is data deficient. So animals that we have here in Miami Beach that are important to us, we often don't even know what the population trends are for them or what their conservation status is. I'm pretty sure nurse sharks, at least here in Miami, are doing okay. But that may not be true in a lot of parts of the Caribbean, where I do some work on subsistence shark fisheries, and they're often eaten by populations that are really dependent on them for food. You guys have probably heard some pretty grim information about shark declines. And the answer is that we really have no idea globally how much sharks have declined, how many we've lost. We can say that in some places, those declines are very severe. In the Gulf of Mexico, since the 1950s, we know there's been a decline of 99.99999% of the oceanic white-tip shark, right? It was once the most abundant large predator in the Gulf of Mexico. It was completely wiped out by commercial longline fishing and the advent of industrial fisheries in the Gulf of Mexico, to the extent that it's functionally extinct now. I've worked in South Florida on sharks for more than 10 years, and I have never seen an oceanic white-tip in the wild. So some declines are really severe and horrifying. We don't honestly know what a healthy pelagic Gulf of Mexico ecosystem is. And pelagic is, again, just a fancy ecologist word for open ocean, right, away from shore. Because those systems were once top-down controlled by the oceanic white-tip. It's not there anymore. Nobody studied it when they were there. So we just don't know what that system used to be like. In other places, these declines are sometimes exaggerated. And so I encourage my students to be very specific when they talk about threats and risks. Because if you say 90% of sharks globally have been lost, there's no data that supports that, right? Big losses in specific places, broadly losses generally, yes. But if you want to communicate with others about environmental issues, I really encourage you to do very good homework, because I think that a lot of times scientists and conservationists who exaggerate to make a point wind up actually discrediting the argument that they're trying to make, even when at a functional level they're pretty much right. So last slide, and then we'll get to some questions because I know some exciting ones are coming in. What threatens sharks? So the biggest grouping is fishing, right? And sharks are caught in targeted fisheries. People are trying to catch them. They're caught as bycatch in fisheries that are trying to catch something else, often tuna, swordfish, mahi. And they're caught by recreational fishers here in South Florida. And in a lot of places, people tend to think that recreational fishing is a small threat compared to commercial fishing. But in 2016, for the first time in Florida, recreational landings of sharks exceeded commercial ones. So the potential impacts of irresponsible recreational fishing can be very large, especially in a place like South Florida that so many people do come to fish. On the other hand, fishermen in general are concerned about the conservation status of sharks, at least here in Miami, based on the ones that I've talked to. And most of them are engaged in catch and release fishing. So we can do things to minimize the harm and the risk associated with that. Everybody's heard about shark finning. They tend to think that the problem there is Chinese people consuming shark fin soup. But the US is the 7th largest global exporter of shark fins. Miami is a major transit point for shark fins coming from South and Central America. So at the very least, we can't really point fingers until we're prepared to not profit off the exploitation of these species. And I try to encourage my students to think about themselves environmental problems, right? Because a lot of times when it comes to the environment, people want to point the finger at someone else because it means that they don't have to feel bad or they don't have to change their behavior. So trying to make sure the ways that we communicate about these problems engage everybody, because everybody can do something to help. Sharks can also be threatened by pollution, both physical pollution and chemical pollution. So lost fishing gear can entangle them. They can eat plastic bags, but they can also be injured by the bioaccumulation of toxic chemicals like flame retardants or mercury, which often build up in marine food webs and can lead to serious health effects in large, long-lived species. I have questions and I'm excited about answering them.
Yeah,
they also
I don't know if you can see all the questions here. We have about 13 questions, and actually our chat has been on fire. People really enjoy our presentation and all the slides. We really appreciate. I don't know if you want me to read them out loud for you, or if you can see the.
Nope, I got them.
All right, awesome.
Michelle is a huge supporter of Shark Angels and asks if they work in Florida. Shark Angels is an organization that is concerned with shark conservation. My experience with them has all been with their operations in South Africa. So I'm not aware of them operating in Florida, but I would be interested to know the answer to that question too. The question do sharks sleep? And the answer is that they don't sleep in the way that you or I do really, but they do enter periods of greater and lesser alertness. And we certainly do see many species resting. So sharks can either be what are called ram ventilators or buccal pumpers. Ram ventilators have to continuously swim to move water over their gills. Buccal pumpers have musculature in sort of what would be their cheek if they were a person that lets them push water over their gills while they're stationary. So buccal pumpers will often lie on the bottom resting for prolonged periods of the day. So yes, they enter lower activity periods where they would be more difficult to rouse, but they're not out the way that humans tend to sleep. The biggest shark I have ever personally encountered, it would have been a whale shark off the coast of Mozambique, quite a long time ago now. But the biggest shark that I've caught as part of my research would be just under 15-foot great hammerhead. If I had to be a shark, what type of shark would I be and why? Tough call. I think I have to go mako or thresher. I think it's like a need for speed thing. I mean, I think I would actually probably be much better at being a nurse shark and just like chilling out and eating whatever. But if I got to be one for one day, definitely mako or thresher. What do sharks eat? It varies a lot, right? We talked about how diverse they are, more than 500 species, but mostly fish. Sometimes mollusks, crustaceans, so crabs, lobsters, squid, octopi, any animal that they can get their mouth around under the right circumstances is fair game. Large sharks like great whites rely more on animals like seals, whales, and dolphins, those kind of high fat content animals. Greenland sharks have been found with reindeer and polar bear in their stomach, so they can get creative, but the vast majority of them eat mostly fish, with some specializing in things like crabs. There are no vegetarian sharks, right? We're talking, everybody eats meat. The one shark that's really interesting right now on this subject is the bonnethead, right? Which we know relies a lot on blue crab as a primary food source. But in the last few years, studies have shown that they also eat substantial amounts of seagrass. And in the past, they've seen seagrass in their stomachs and said, this is incidental to the capture, right? So they're going after a crab, they get a mouthful of seagrass, they swallow it, but they're not really eating it. But recent studies have shown they're eating it and they're getting nutrition from it. And that, in fact, their gut microbiome, so the bacteria and organisms that live in their guts, are able to break down seagrasses so that they have similar digestive efficiency for seagrass of juvenile green turtles, which is really incredible and not something that we've at least discovered yet in any other species of shark. Everybody else is fish, crabs, animals. People should not touch sharks. Yes, that's true. Sorry. Both for your safety and for the animal's safety, it's better to never touch a wild animal. Some sharks, like tiger sharks, put a fair amount of energy into producing something called a slime coat that protects their body from parasites and from injury. And if you rub it off, they have to use energy to produce more. You also run the risk, obviously, of injuring them, of annoying them, of injuring yourself. So shark skin is actually, it has the same basic structure as shark teeth. Their skin is made up of tiny teeth called dermal denticles, which comes from the Latin for tiny skin teeth. And they're sharp. If you touch a shark from the head towards the tail, it feels smooth, but if you rub it the other way, it feels like really rough sandpaper. And they'll tear you up. So it's a bad idea to touch any animal in the wild. And it's an extra bad idea to touch ones that could hurt you. For whatever reason, people don't have the same filters with marine animals as they do with terrestrial ones. Like, everybody gets that it would be really dumb to walk up to a bear and touch it. But for some bizarre reason, people don't make the same obvious intuitive leap when it comes to sharks. What do I mean by a sharky shark? Great question. So if you ask people to draw a shark, right, almost everybody will give you something, a body plan that looks pretty much like the one on the slide, right? Like a sort of pointy nose, that dorsal fin, that lunate-ish tail, and those pectoral fins on the side. Like, that's the body plan almost everybody would draw. But a lot of sharks don't actually look very much like that. You know, nurse sharks look pretty different. The sharks that do look like that, for the most part, are from the order Carcharinidae, right? So we call them carcharinid sharks. There's some exceptions to this too, for sure. But usually if I talk about a sharky shark, I'm talking about a shark from family Carcharinidae. What is pupping? So that's just the process of a shark giving birth to baby sharks. Sharks use a couple of different reproductive strategies, right? Sharks were the first animal, we're pretty sure, to come up with internal fertilization. But some sharks lay eggs. Some sharks fertilize eggs and then let them develop inside their oviduct, like inside their body, and then give birth to live young. but those eggs develop inside the body without any inputs from mom. You know, once the egg is there in the oviduct, she's not doing anything. And then some sharks have placental connections to their offspring, very much like mammals do. Lemon sharks are a great example of that, where they have a placenta and an umbilical cord. And actually baby lemon sharks have little tiny belly buttons, but they're like right on their throats. But so pupping is the process by which, not an egg, I wouldn't say pupping for laying an egg, but either individuals that hatch inside mom and then are released, or individuals that are being born more like mammals are released into the environment around them. Cool fact, mom sharks actually release hormones that suppress their appetite when they give birth so that they're not tempted to munch on their pups. And people are always like, oh, sharks are so horrible that they need to do that. Humans release a very powerful blast of very similar chemicals when they give birth so that they're not tempted to smother their annoying screaming babies in the immediate moments after birth. So we're all just animals. It's super cool.
And Catherine, we are starting to run out of time here. So if we can do one more question, and then what we can do, guys, we can follow up with Catherine afterwards and, you know, provide you the answers on that. So we can start moving to Kahoot and the myths and the facts.
Oh no, I want to answer them all.
I know,
Okay.
it's so amazing.
Okay, so what is the gestation period for sharks? I see that one. It varies a lot, right? There are individuals that have quite short gestations, but also the frilled shark, which is a cool ancient species of deep sea shark, has the longest gestation of any known vertebrate on the planet. It's 3.5 years from implantation to birth, so really long time. Females of some shark species can also store sperm for later use after mating, so they don't have to become pregnant immediately. They can wait till conditions are good. Do sharks recover quickly from being hooked, or does the injury persist for a while? Great question. And the answer is a little bit, it depends. So there's sort of two separate questions, right? The injury from the hook itself, and in general, that heals very quickly. Animals that I've seen recaptured 2 weeks after a previous capture usually no longer have a visible injury from the previous hook. It depends a little bit on how much damage is done with the hook, which is one of the reasons we sometimes cut them rather than trying to pull them out. I'd rather spend the extra money on replacing a hook than do more damage to the shark's mouth and jaw. But the stress from being captured, for some sharks, they recover pretty quickly. Nurse sharks, tiger sharks, even if you stress them out, they'll swim away. They're buccal pumpers, right? So they can lie on the bottom and breathe. They can sulk about it for a little bit, and then when they feel better, they're good to go. Ram ventilators tend to have more trouble handling the stress of capture. So blacktips, hammerheads, black noses are more likely to die from capture stress. And when you release them, if they're not in good condition, they can't go lie on the bottom and rest, right? Because they can't breathe. So if they can't swim away, they won't survive. So it varies a lot depending on how difficult the experience of being captured is for the animal and how quickly you're able to handle and release it, and how good it looks as it swims off. For some species, mortality from catch and release fishing is as high as 50%. For other species, it's a very minor risk to them. You know, they released alive a nurse shark that somebody like took on the metro. So sharks can be super tough. Sharks can be super delicate. You always want to handle any animal as though it's vulnerable to give it the best possible chance of survival. Okay, you said 2 more, that was 2, I'm good.
All right, thank you so much, Catherine, and thanks for everyone for, you know, being so engaging and asking questions. We really appreciate it, guys. All right, so we are going to talk about your shark knowledge right now for the folks that are here watching us, and we want to hear from you guys. Is that a fact or is it a myth that sharks are man-eaters? And before Catherine responds and talk a little bit about it, I want to hear from you guys. Oh, look at you guys. You guys are doing so well. Yeah, everybody doing it. All right. And here we go. Catherine, all yours, if you want to talk a little bit about it.
Yeah, we touched on this one already, but definitely a myth. One of the things I like to point out to people is that a shark that was starving, in some cases would starve to death faster if it ate a person than if it ate nothing at all, right? Because we have all these dense mammalian bones. The amount of energy that it would get from the meat is probably less than the amount of energy it would spend trying to digest my bones. And secondarily, even sharks that eat mammals, right? So like great whites that eat seals. They tried in South Africa to attract them using blood from a slaughterhouse because they figured it would be cheaper than buying tuna to attract them. And what they found was that they would not come to cow blood. It did not smell like food to them. It did not appeal to them at all. So yeah, sharks don't want to eat people. If they did, they would do it a lot more than they do. And then also just think about how big a great white is. You know, the fact that anybody survives a great white attack tells you that that great white is not interested in eating a person, because if they were, once they had their mouth on you, you'd be done, right? But most of the time, they get a look at you, they get a taste of you, and they say, oh my God, this was a huge mistake.
Thank you, Catherine. All right, next one. All sharks look the same, large with lots of sharp teeth. And Catherine touched on that too, guys. So let's see. All right, look at you guys doing so well. Ta-da! And here you go, Catherine. I know that you put that picture in there, so I don't know if you want to quickly say anything about it.
Nope, I'm good. We talked about how diverse shark species are, more than 500 species of shark, over 1,000 when you include rays as well.
Awesome. Okay, the next one. Sharks can go into a trance. Can they? I'm wondering. Don't give the answer, Catherine.
I was nodding at something someone said in the chat. I was not responding to the
All right, let's see it. Woo, look at the picture. Do you want to talk about it, Catherine?
Sure. So tonic immobility in sharks, which can happen either from rubbing their face or more often from flipping them over, is probably an evolutionary adaptation that facilitates mating, right? But is also really helpful for us shark scientists. And I saw Layla saying this in the chat. Thank you, Layla. But also photos like the one of me earlier handling a shark being done for permitted research. I have a PhD, I have 10 years of experience. So when I say people should not touch wild sharks, I'm exempting myself, which you can object to, but I do indeed have state and federal permits to work with those animals and quite a lot of training. So one of the cool things about tonic immobility is that you can actually flip a shark over and perform a surgery on it without anesthesia while it's in that tonic immobility state. And in fact, the evidence from the veterinary medicine literature suggests that that is much less dangerous to sharks than trying to actually anesthetize them. It's come in very handy for shark scientists as an ability, but it's not equally true for all sharks. So if you ever find yourself trying to put a shark in tonic, use caution.
Yeah, please don't try that at home, guys. Maybe with your cat, but not with a shark. All right, next one.
It also works on chickens and alligators, though.
Oh, cool. Very cool. All right, sharks fill an important ecological niche as predators. What is it, guys? Is that a fact? Is it true? Is it false? Oh, here we go. I don't know what happened, but here it is. And I think we talked about this one too, right, Catherine?
Sure did.
All right.
They're important to helping to maintain healthy oceans.
Here we go. Awesome. All right, Catherine, thank you so mega much. You are amazing. That was so much fun. We love it. And we'll be following up with you with all the questions we have. You saw 300 questions out there to be answered. And now, the moment you guys have been waiting for. It's Kahoot time. All right. Jenny, I'll let you take it over so we can start our Kahoot. And guys, as the screen shows, please take your phones to the Kahoot.it, and Yanni will be sharing the pin on the screen so you can enter your nickname. And then we'll see if you guys will pay attention, how everybody's doing.
Thanks, Flavia. I'm so happy you guys are here. So Flavia's portion of the presentation was really a warm-up so that we can get prepared for Kahoot, because this one actually has prizes. So make sure that you guys have your phones ready. I'm going to pull up the screen so we can get started. I know we're running short on time, so we'll try to do this as fast as we can. Give me a second and I'll share the screen with everyone. Perfect. Do you guys see my screen? Awesome. Okay, let's get started. So make sure you put in the pin that you see at the top of the screen onto your phone. One of the things that we want to mention is that you're not only getting points for getting the correct answer, but also how fast you answer. We'll give everyone about a minute.
And while you wait, you can dance.
So it looks like we're stopping. Oh no, we have more people coming in, because I know we have a good number of people, and so this is only a portion of you so far. Okay, so I guess we'll get started with 22 players. All right, sharks are older than. Good job, everyone. I'm happy no one chose your parents. All right, it looks like we have Michelle at the top. All right, let's keep going. True or false? The majority of sharks live in salt or brackish water. Let's see who's up. Oh, Michelle's still at the top, and we have Paisley right behind her. Sharks have a sixth sense called? Oh no, Michelle. Paisley's at the top. All right, next one. True or false? A baby shark is referred to as a pup. This one should be easy. Next one. Gauzo. Okay, awesome. And we have Mako, and then Paisley went to 3rd place. Next question. What type of predators are sharks? Definitely apex predators. All right, so I think this is the last question. Oh, Mako went to the top. Paisley's in 2nd place. Today marks the blank anniversary of Earth Day. Another easy one. You guys aren't thinking. Yep, it's the 50th anniversary. That's why we're having these great workshops. All right, so the winners are Dara. Oh, Super Dara, really. And top place. So what I'm going to do is in the chat, I'm putting in my email so that everyone who won can reach out to me so you can claim your prizes. And so now what I'm going to do is I'm going to turn it back over to Flavia to cover one more portion.
Right. Here you go. I'm taking it back. Can you see my screen right now, Yenny?
Yep.
All right. So before we end up, I just wanted to give the opportunity for Catherine to say a few words. I know that she really want to answer all the questions. I wish we had more time. I do. I really do. And so before we wrap it up, Catherine, again, floor is yours.
I just wanted to thank you guys all so much for being here. It was really fun for me and hopefully for you to get to talk about sharks for a little while. But if you have questions and you really want an answer to them and we didn't have time to get to it, please do email me. I'm like really, really happy. You can tell I'm really happy to answer that question for you. So just reach out. My email is my name, Catherine MacDonald, catherine.macdonald@rasmus.miami.edu. So please do check in with me there if you have questions about sharks we didn't get to. Thanks, Flavia. Thank you guys so much for inviting me.
No, thank you. Thank you so much, Catherine. That was amazing. We really enjoyed your presentation. Thank you so much for taking the time. And guys, this is all going to be downloaded to our website. So, you know, you can watch again. You can get more information about Catherine's organization if you would like to go, you know, learn more about sharks with her. So feel free to reach out as well. And I wanted to end up just with a note on send you guys lots of love and gratitude. And again, we are here to support. If you guys have any questions or any suggestions, please send on our way. And again, thank you so much for joining. Thank you. And I'll see you guys. Oh, on Friday at 4 p.m., we'll have a lot of cool stuff coming on trees and plants. So if you want to become an expert on that, join us. And the cool thing is we'll have County of Maui from Hawaii joining us, and the Botanical Garden from Maui will be joining us live. So stay tuned and join us on Friday. Thank you again, guys. Have a great day and happy Earth Day. Thank you.